Recording in progress.
Start the recording. I'm going to start the recording. I'm going to switch over to. All right, to the calendars. You should be seeing the calendar. We are now have started. So as I was saying today, I've been thinking about the format of the class. So far I've introduced transfer learning, fastai, and then also the the Hugging Faces Transformers module. And today is January 31st, so that this week we will be continuing with fastai. But my issue with fastai is that is mostly image processing, a lot of image processing, which is important. I'm not saying it isn't, but to me, being a natural language processing person, you know, NLP is also pretty big. And so I kind of what I was thinking about doing is, let's see how it goes, is the first half we're going to do fastai, the second half we're going to do the transformer modules, and that way we get to see both things, right? And it should be doable, I think, instead of spending so much time, because by the time we get to, I was thinking by the time we get to after spring break, and you guys will be tired, and then you won't have as much energy to hit the NLP stuff. So instead, I think this is a better approach. So today the plan will be, fastai. The topic is images, loading your own images. So we'll talk about that, and then after that we'll talk about the transformer modules, and I'll assign, in both cases, a homework. So I'll assign a homework in the image processing one, and I'll assign a homework in the NLP one, although the NLP one will be a much bigger, it's almost like a mini project. So that homework will not be due next week, let's say. Does that make sense, guys?
Yep.
All right, great. So it should be better, I think, more interesting, more fun to do it like that. So a couple of things. Let's go back to Brightspace, because I did rearrange some things in my GitHub in particular. So as you can see here, I think these links are now, they may be broken. No, this takes you to Hugging Face. Okay. But this one, the fastai one, may be broken now. Yeah. See, it's broken. Because I did change it. So I'm going to, I reorganized basically. So I'm going to get rid of this one. And also, this was the assignment. I'm pretty sure this one's broken. And then I'll update them, but I'll just show you the new structure. I think it'll be a little bit better. Okay, great. So that's taken care of. So let's take a look. So now if we go to the GitHub, actually, I'll show you where everything is, because I uploaded a lot of files. But everything, so you should be seeing the GitHub now. And if you go to repositories, you click on that, you'll see a new one called transfer learning. Okay, transfer learning. So if you click on transfer learning, now you can see I added 2 modules, Hugging Face Transformers, and then fastai. That way, pretty much what we're doing in the course is under this, all of it. Under the fastai, this is what we did last week, right? And today we're going to be doing this one, dataloader, your data. So we'll be going through this code, but it's mostly image processing. And then so that way, now you can see I added the Hugging Face Transformers now, and I organized the code into several categories. So data sets and tokenizers, excuse me, which are essential to creating, training your own models. There's intro here, which is what I'm going to focus on today, and then other advanced topics like fine tuning. So intro, as you can see, this is where I have all the Albert, Electra, Roberta, and all of these. Did you guys try running? And I know we tried like a couple of these last week. Did you guys try to run any of these on your machines? Guys?
I didn't.
You didn't? Did anyone try them?
I did. I ran a couple of them.
And they ran okay? Like you ran Albert test and it ran?
Yeah, it's just a little slow because I'm working off of Windows.
Like how slow? Like how slow?
Slow. I know one at least took 30 minutes.
30 minutes. Okay. Yeah, because the first project will be basically just using these Albert, Bart, you know, some of these to solve a problem. I'm going to give you guys an actual task. Yeah. So I'm going to give you guys an actual task. And I just, yeah, and I'm going to ask you guys to really like solve it. It'll be a very interesting, I think, topic where you have to think, you know, but you'll, the key thing is you will need to use some of these tools. Okay. So just use them, not really do that much coding, or you'll see it's, but we'll talk about it during the second half of the semester. I was thinking about that, and it's actually a very interesting project. So anyway, so that being said, I've given you now the format where everything is. So I'm going to create for this one, I'm going to create the link. And then we're just going to get started with the code. So today we are doing, what is it? Data loader your data. Let's call it that. Data loader is a module in fastai. And you're going to run your own data. You're going to have to, this will be a homework assignment too. This is the homework that will be due next week. So you will have a homework today based on just on fastai. As I said, the transformers will be a mini project. So I'll give you a few weeks to work on it. And then we'll discuss it in class, how you're doing and everything like that. Does that make sense? Okay, so now let's get started. I'm going to start. My computer should be running upstairs. So I'm just going to go ahead and log into it. Okay. Give me a sec. It's not connecting. Hold on. All right, let me restart. That thing is not. Okay, so recording, audio, video, we're all set. All right, so as I was saying, so right now in this half, we're just going to look at fastai. We're going to build something from scratch, basically. So all right, so the topic of today's discussion is the data loader. So I'm going to create a new one here. Python. So we saw last week, you know, these data loaders, and we were basically just bringing in data that was already built into fastai. So we brought in like, you know, some text processing, I think, and we did some for driverless cars, things like that. So, you know, given that fastai is very focused on image processing, you know, our first day and deep learning, really. So we're gonna focus on images. So we're going to do that. So let's take a look. This will be a data loader, and in particular, also we are going to bring in our own data. Now, for the homework assignment, I already provided a data set, which is posted on GitHub. I'll show you in a second. It's a fruit data set that I always use. So I will demo today with that data set. What you will have to do in your homework assignment is you will have to find your own image data, but I'll show you an idea. We're going to use the Bing. Bing is, for those of you that don't even recognize what it is, it's a browser, right? It's the Microsoft browser, and they have an API for image retrieval. You just have to sign up for an account. So that I'm going to discuss that solution, but it should be practical for getting the images, and then that's it. So the homework assignment for this week will be basically using this code, which is already posted, but instead of using the fruit data that I have, I want you to find interesting images, okay? I want you to find an interesting set of images that you can use, okay? So that's actually the whole point of this. Given, you know, I want you to think about this class in this following way. Instead of focusing all the time on the algorithm or the machine learning, or do I have these many layers, instead we're using pre-trained models. So then our focus should be on interesting things, right? On interesting, like the data science itself, okay? What are we trying to achieve? So I want you to find, you know, images beyond like, you know, is this a cat or a dog? But actually find interesting things, interesting images, and so on. All right, so the first thing we're gonna do is we're gonna look at, you need to download the data set. Now I have already done that. So if you look in the books here, in the Jupyter notebook, I already have a folder called fruits. Do you guys see that? And if I click on fruits, are you guys seeing this? In the fruits folder, I have apple, banana, pepino, pepper. So 4 fruits. Then if I click on apple, you know, I have a picture of an apple and so on, and you should be able to see that there. And so I have about a lot of fruits in each folder. I didn't do the count, but I think there's at least 100 in each one. Okay. So this data set you will need to download. Okay. Because we're going to be using. So to download the data set, you can go here. To download the data set, you can download it from here, from the GitHub. Just go to you'll need to go to this one, Deep Learning ML and TensorFlow. Click on that. And then go to Convolutional Neural Network, CNN. Click on that. And then RGB. And if you look at RGB, you will see that there's a file called compress RGB CNN.zip. So download that. And that should give you a few images, not that many, but it should give you a few images to be able to, for the code to run. Obviously, you will need a lot more images, right? So that means you need to download some interesting pictures, but we'll talk about that once I finish the demo for today. Any questions? All right, so let's go ahead then. So we're here in our, so you've seen that my Jupyter notebook is in a folder. In that same folder, there's a folder called fruits. Within that folder, there is other folders for the different types of fruit, apple, banana, and then inside is each individual image. Well, as it turns out, the data loader of fastai, the class, is very flexible. And one of the things that it will accept is that you store data like that. So if you store data like that, it'll be able to read it. It'll understand that the main folder is fruits. It'll understand that the subfolders are the classes, and then it'll understand that the files inside are the actual samples, okay? So that's actually quite convenient and handy. Another approach is being able to read the data from a text file, for instance. That's another approach. All right, so let's go ahead then and take a look at, remember, this is data loader class, but with your own data set. I've already talked about the data set, so now I'm just gonna bring in from fastai.vision.all import all. Okay, and we need to specify within this from fastai vision all, we have a function called path. Path allows us, as an object that will allow us to define where things are located. So currently my images are in this same current working directory, but under the fruits folder. So I just need to specify that. And then when I do path over here, you can see now I have the path, okay? If I want to get the images, all I have to do now is we're gonna use a function built in called get image files. So get, remember, these are all built in within the fastai module. So get image file. You see that? Let me make sure. Okay, so get image files. We need to specify in here, you know, a variable FNS, let's say, for the files, file names. And then in here, we got path. So the actual data always stays in the folder. You're not like taking the data and loading it into RAM somehow. The data stays in the folder as it should, because you could have millions and millions of records. The only thing that get image files does is that it should give you a list of the paths. So if you look, for instance, if I do FNS here, if this runs, there you go. You guys see that I have the folder fruits. Within it, there's pepper, and then the individual file names. So it doesn't, this is the list of everything contained in there. Okay, guys? So that's the basic idea. And so this is how fastai does it. It allows you to collect your data. So once you have your data, you will also, I suggest, create it in this folder, and then you will just be able to run all of this. We will do classification, or, you know, basically the entire pipeline of machine learning here. But the only difference is you have to use your own data set. Okay. I'll provide a script later as part of the homework assignment on how you can do that. Any questions so far? Any questions? Making sense? All right, let me grab some coffee. All right, the next step is to call the data block, basically. So the data loader, yeah, so, oh yeah, the data set is located there. Thanks, Kyle. Yeah, so remember this data set, because GitHub doesn't let me load that many images, doesn't have as many images as I have, okay, guys? But it should be enough that you can do a little bit just to try out the code. And then later we will, you know, as part of your homework, you just have to collect enough. But I'll provide that API, as I said. Okay, thanks. All right, so the next thing is, as I was saying, the data loader. Yeah, it's a zip file. All right, so this is the data loader. And here we're going to basically, I'm going to write it out and then I'll describe the individual things. But it's similar to what we did last week. So here we just defined, there are many of these, but this is called a data block, for instance. Okay, so data block, right? And then we're gonna specify the contents of this, of your image. So the first thing you can specify is blocks. This is kind of like the tensor that has the data. So usually what you do is you specify a tuple where you simply say, these are all FastAI convention names. You'll say, that, you know, the data is an image block, right? Followed by a category block. And the idea of a image block is just means a tensor of images, and then a category. So, you know, you have 64 images, a batch of 64 images, and they are MNIST, so there's 784. So it could be 64 by 784. And then the category block would be 64 by 1, because it would just indicate the class, okay, the label. But this is how you specify it. It's basically, you know, as long as you specify it like this, FastAI kind of figures out how to read the data with the labels, because then it knows the labels are the subdirectories here. So that kind of comes out really handy, and it saves you a lot of time. You know, if you remember, we've probably done this in pure PyTorch, pure TensorFlow before, and in other classes, and you know, it just took a little bit more work. So that's the blocks. Then the next thing to do is, how do we get that data? So, you know, if you remember last week, we were using something, get image files. So we from get items, how do we get them? We use the get image files, which is the one that you can see just above in the code. Get image files is this one, right? And so get image files will just return basically this. So you can see how FastAI will get something like that, and then it'll be able to read the data. The next thing that we want to specify is how to split the data. So we're going to have the splitter. Remember, this is so that we can do the train and the test. So random splitter, random splitter. And then we're going to specify the, you know, it's validation here. So valid %. So PCT, and it's going to be equal to 0.2 in this case, right? So 20% of the data will be held out for testing. The rest for training. Remember that the data, when you do a random split, it randomizes it. So if you want to get always the same set of results, just do seed equal 42. Okay. Now that we've specified the splitter, we have to specify how do we get the labels. So get y. Right, so get y is going to be parent label. And what is parent label? So we can probably define parent label as one of those built-in functions in fastai. Fastai has, it's like it's taken every possible code that they can think of and created little functions for you. It's very handy, actually. I like it. So parent label simply gets the name of the folder a file is in. So that, that's a pretty good definition. So it simply gets the name of the folder a file is in, and that way it assigns the class. So pretty simple, straightforward. So now that I have that, that's the function that gets me the label. And then the last part is the transforms, or the transformations. So item transforms, not to be confused with transformers, right? So this is just the transformations that you would apply. Remember that this is the pipeline of normalizing, resizing the images. But we're going to learn a few other things today, a few other tricks. That should be pretty interesting and nice, and actually will allow you to increase your data set. There's something called data augmentation. I'll talk a little bit about that today, and fastai does it nicely, and so you can play with that idea as well. So for this one, for the very basic one, we're just going to resize. So resize the images. Remember, for instance, we had said that the ResNet 34 expects images of size 228, I think. So we got to resize them to that. But you can resize to other things, and depending on what you want. So let's say 128. So this is resizes to 128 by 128. Now keep in mind that this resize, whenever you apply it, it basically by default, unless you specify otherwise, it crops the image. Okay, so you're going to lose some information there. Okay, so there we have it. We've specified a data block and assigned it to fruits. We've created this object. Now what we can do to use it is we're going to create the DLS object that is now the data, and I'm going to call fruits dot data loaders, but we still need to specify. If you notice, the path was never defined here at all, so we still have to define it here as path. Okay, so now let's go ahead. Let's see if it works. Okay. So it should have read my images. It should have loaded them. I'm not seeing any errors, so that's a good sign. Now, yeah, so one other advantage of this, remember that when you're processing GPUs, you don't just want to give one image at a time, right? You don't want to just give one image at a time. Instead, you want the data loader to give you the data in batches. All right, so in this case, by default, the batch size is 64. So just be aware of that. It would actually make no sense for you to use a GPU and just give it one image at a time. Then might as well just use a CPU. The advantage is in the batches. All right, so by default, it will give models batches of 64 for training and testing. Now let's take a view of our data. So to view, we can do DLS dot, and we're gonna select here. Notice I could type train for the train set, or I can type valid for the validation set, okay, guys? And so now I'm gonna do show batch, and I'm gonna specify how many I want. So I can do max n equal, let's say I want to display 8. And I'm going to specify that I want, if I say just one row, then the images will look very tiny. So instead, I'm going to say number of rows 2. That way, it should display 4 per row. So now I'm going to run this one. And there you go. You see, we've got our, in my case, I got the images in my data set labeled and everything. So I've got apple, pepino, 2 types, banana, and you can see that the pictures have different shapes, etc. And I have not augmented the data. This should be the original one, I believe. Although I was playing with it last night, so it could have some of the augment, but I don't think it does. All right, so that's basically the fruits so far. Are there any questions at this time, guys?
I'm here.
Making sense? All right, good. Yeah. All right, great. So now that we have, so now you know, for instance, how to load your own images, right? So any problem, think about it. Now any problem that you have, boom, you know how to load your images in the data set. Then you're gonna load ResNet CNN Learner, pre-trained model, fine-tune it, and use it. Okay, so that's basically the idea. So let's see, now that we've done this one, let's take a look at a few other the resizing, as I said here, that basically I should say this is transformations. So the transformation of the items, right? We have several options. By default, it just crops, but we can actually try a few other techniques just to see what else is available. So let's say, for instance, instead of cropping, right, we're going to try a few other things. So for instance, we can pad the images, we can squish the images. So let's try, and this may not be that useful with the fruit here, but when you guys do your homework assignment with your very interesting data sets, you may be able to get, more functionality out of these. All right, so I'm just going to do fruits. Oops, sorry. I'm going to say this is pad images instead of cropping, so that way you don't lose data. It just crops to a white background or whatever it is. So let's do fruits. And then, we're going to call the object fruits.new. And now we're going to specify a transform. So I'm going to say item underscore TFMS. And I'm going to assign to it resize again to size 128. But this time the resize method will be .pad. So we're going to pad the images so that way we don't lose any data basically. It should be uppercase pad. And so here the padding, we can actually specify what we want. So the pad mode will be 0s. Okay, so the pad mode will be 0s. And what that means is, like white background, etc. So once we do that, we can go ahead and load the data again. DLS is going to be fruits dot data loaders. We call path again. Okay. And we now show So I'm going to do DLS dot train this time dot show batch we're going to specify n max of size. Let's make it even bigger this time. Oh, sorry, max n. So max n, and let's make it 12. So it's going to be 3 rows. 3, like that, right? So let's try that one and just see what happens. Oops. Okay, so I'm going to run that one. And you can see the images there. Basically, they've been resized to 128, but without losing any data. Now they just have maybe more white background. Okay, does this make sense? This will be very important for you guys because in the homework, you're going to use Bing, right? And Bing is just going to give you a whole bunch of images of whatever you ask for. And so, but they're going to be in different sizes. There's going to be a lot of noise. This data set is a very clean, very nice data set. So you'll have to resize them to the appropriate dimensions. Let's try the squish approach, squishing the images. So let's do squish the images. And in this case, I'm going to do fruits, and then fruits dot new. And then the transformations again. So item TFMS. I'm going to resize it to size 128, comma. But this time the resize method is going to be squish. So this one may not be so great because for the model, we're teaching the model based on squished images, but the real world is not squished, right? So just keep that in mind that it's convenient, but possibly not the best solution. So resize method dot squish, just like that. So we have that approach. So now I'm going to do DLS, and we assign to it fruits dot data loaders path. And then DLS dot, let's try this time. What did we try before? Train. So let's do validation. Show batch. Show batch. And let's do max n equal, let's do 4, 8, 16. We'll do 4 rows like that. Okay, so we're going to try out this one, see what we get. And there you go. Now my images don't look that much squished. I saw that before, and it could be that they're proportional. I think if you guys have images that are highly improportional, like 200 by 500, they'll look more squished than say mine. You guys understand that? Yeah. All right. Now let's take a, so can you guys hear me?
Yeah.
So now let's talk a little bit little bit about something called data augmentation. It's a nice trick out actually. So look at the images that we have here. They all look like the fruit is at the center, good background around it, right? They all kind of look like that. But images are not always going to look like that. Let me see. So we just did squish and cropping. All right. So usually what we want is, you know, when let's say you were building a wolf detector, right? So a wolf detector. So the pictures of wolves are not always going to be like the wolf with its face like in front of you, you know, looking at you, growling, right? It's going to be the tail of the wolf, the foot of the wolf from the back, from above, the wolf maybe in profile, but it turns the head right away. So the images are always going to be very, they're going to have a lot of variation, basically. And so data augmentation is this idea that you can take images, the original images, but now you're going to crop them in strange ways. So it's like, imagine like a camera zooming in and zooming out. So the camera just zooms in, you know, and it just captures that. You see that? So it just captures that piece, or it zooms in on the apple and now it just kind of captures something like that. Or, you know, it kind of intentionally, it moves it so that even though the banana looked like this originally, now the algorithm has made it look the opposite, flips it. So that's data augmentation, basically. It's this idea of taking your original images, applying some techniques, and then changing them, okay? Changing them to be just cropped more, just a piece of it, or even flipped or changed in some way. So we're gonna try that approach with fastai. This is sometimes called the random cropping because, as you know, as the name states, you know, it's going to pick a point on the image randomly, and then it's just going to crop around it. Okay, so we're going to call this random cropping. Okay, so random cropping of an image, and this is considered better. Okay, because of what I said. So let's try out a couple of variants of this. So I'm going to do fruits. And then we're going to do fruits.new. Again, the item transformation. So item PF MS. Okay. And we're going to now notice we're going to use the random resized crop. We're still going to tell it the size of the image, of course, 128. But now it's going to pick a random spot on the image to just crop that and then resize it, okay? Now, it also has a parameter called minimum scale. Which, as we will see, it basically says what's the minimum amount of the image that it should retain, right? So like it shouldn't, you know, that you can control. So you can say like how much of the image I want to retain, because certain images will be, you know, different than others. And so you don't need as much data. So you can control this. The best thing for this part for your homework will be to just play with it. Look at the images, do a good analysis of it, and then maybe you'll find a good balance. Then we're gonna do DLS fruits data loaders. Okay, and again we're gonna call in path, and now we can just print out. So I'm gonna do DLS valid dot show batch. And let's just print out a few from the validation set. I'm going to do max n equal, let's say 4 and just 1 row. So n rows equal 1. All right, so we're going to take a look at what these images look like. And if you notice the images, maybe we should do a little bit more. 4, 8. Well, let's do 16 again. 4 rows. Okay, run it again. Oh, there we go. So you can see now they've been cropped. You know, before you could see, if we look carefully at the images before, we could see the entire pepper, the entire apple. But now if we look, they have been cropped a little. Look at the pepper has been, banana's missing that part. And so you can see they have been randomly cropped. Any questions on that one? So that's the idea. And then after that, we can just play with this. So I'm just going to change the parameters. Now, if you just want to see, let's say, one single image, you can add a parameter here called unique. And that will give you, just for one image, it gives it kind of outputs. So you can also try that one. You can say unique equal true. And you can see now it's just showing apples and how it did it. Let's change this to train. And you can see here, this is a much better one. You can see how randomly it cropped the images. It's almost like, imagine like if you just had taken one picture of a pepper, but this is as if you had taken multiple pictures of the pepper, right? And so that's kind of nice, kind of neat, because it allows you also to increment the size of your data set. And actually it makes it more robust in a sense, as in the real world, you would look at peppers from different angles. Okay, so we talked about random size crop. And yeah, and then you can just play with the rest of it, play with this parameter minimum scale just to see what happens with and without the true and unique, just to kind of see what you get. Is this clear, guys? Any questions so far? All right, no questions, it seems. All right, great, making sense. All right, good. So now we're getting close, so we're gonna finish up the data augmentation, and then we're gonna do the machine learning part. So let's go ahead and let's do, we've done the random cropping. Let's take a look at more data augmentation here. Data augmentation. And in particular, you're going to want to do things like rotation, right? Flipping, you're going to flip the image. You guys know how to, you've probably done that in your Paint or something. Perspective warping. These are just some of the built-in things that it has contrast and brightness changes, right? So these are all kind of the built-in augmentations. Now, what's important about this one is these algorithms can actually be quite intensive to apply, right? And so fastai will do this on the GPU as well. So that's actually kind of nice because it'll speed up. So these are via GPU intensive batch transforms, okay? So that's a nice feature. Okay, so let's go ahead then. We'll do the same I'm going to do fruits. And I'm going to assign to fruits, fruits again. Dot new. I'm going to add yet another item transform. Item TFMS. Right, so I'm assigning a new one over here. It's going to be a resizing, because we always have to resize. So resizing of size 128 for this one. But now we're also going to apply a batch transform. Okay, so we're going to apply a batch underscore TFMS transforms. And in this one in particular, it's going to be augmented transforms. Right? And if we specify multiple ones, let's specify, let's say 4 of them, mult 4. So now let's go ahead, DLS, fruits dot data loaders. And we're going to use path to read in our data, of course. And then DLS dot train dot show batch. So here we want to view a few more. So let's do max n equals 16. We're going to look at them from the train set. And we're going to have n rows equal 4. Okay. Let's try it. So you can see the GPU worked. It's not an error. I think it's just a warning. We don't really have to worry about that warning because it's a fastai warning, unless my PyTorch version is old, but I just installed it. Do you guys get that warning as well?
Yeah, I did.
Okay. But as you can see here, if we look at the images, it's kind of neat, right? It's kind of nice. We can definitely see there's a little bit of like warping. Look at this image, for instance. Do you see the brightness of it? So it added that brightness, contrast, etc. So data augmentation is kind of nice because it would reflect in reality, right? That sometimes you take a picture, there's too much sun. Sometimes there's less sun. Sometimes you look at it from this angle, that angle. And so it's kind of neat. Any questions? We can also do the unique equal true so that we can just look at one image. So unique equal true. And that should just be one image. So if I run this, and there you go. Look at now we have a pepper. Look at this one, how it, maybe it's really bright, sunny. This one's really dark, and various other ones. There's a little bit of blur going on there and so on. So data augmentation is definitely a nice, especially in image processing. I don't know that you can apply it in natural language processing, I suppose, but certainly in image processing, it's a little bit, kind of makes more sense, I guess. Any questions? All right, so we've been playing with all of that, and now we are ready. So that concludes data augmentation, right? We've looked at it. Basically, we've looked at the individual transforms, padding, squishing, random resize crop, and then the data augmentation transforms. We tried 4 of them. So now we are ready to, use our CNN learner. So now we're going to go ahead. So now fine tune CNN Learner. Remember, we learned about this one last week. This is the built-in CNN Learner trained on ResNet 32, although we can try other ones. So now fine-tune CNN Learner with our data. As you can see that there. So we're going to now load the data formally. So I'm going to do fruits equal fruits dot new. And then in here, I'm going to do item TFMS. And we're going to use the random resize crop. Okay. But we're going to specify 224. Remember, that's what the CNN Learner expects as a dimension. And we're going to do min scale equal to, say, 0.5 for the cropping. So it should retain, but it's going to be a random cropping. And we are also going to apply the batch EFMS transforms. And we're going to use the augmented, so data augmentation, so augment transforms. Just like we did before, in this example, augment transforms, mult equal 4. I leave it to you guys to play with that value, but just, try it out. So that's it. So as you know that you define your data loader, if you will, now we call in the data set so that we can actually use it. So I'm going to do fruits dot data loaders, and then in here we're going to specify path. Okay, and now we have our DLS. So if you remember, all we have to do is create the learn object. So learn. I'm going to do CNN Learner. This is a convolutional neural network that we've been using. And now we plug in DLS. We're going to use ResNet Notice 18, just for a difference. You guys can try different ResNets in your homework assignment as you see fit, as you think it works best. And then the metrics, we're going to use the opposite of the accuracy, so the error rate. So we're going to say metrics. This data set is balanced, so it should be okay. Error rate. Okay. And then finally, now, remember, that just brings in the pre-trained model. We still need to fine tune it. So then we're going to do learn dot fine tune, and we're going to run 4 epochs. Remember, 4 epochs means it's going to look at your data 4 times, and it's going to adjust the last set of weights given your data set. Okay, so given that this is done, let's go ahead and run it. When I tested this, it did pretty well. So there it goes. So you can see the loss is already pretty low. So the loss actually jumped from one epoch to the other, from 87 almost to 0 immediately. Because this is a very easy problem, the colors are pretty obvious. So with your images, it won't be this simple. Okay, we'll talk about your homework. Okay. We will, as I was saying, we've done this processing, it went to 0 really quickly. So our model is done, right? Basically done. Any questions, guys? Guys, any questions? All making sense? Nope. All right. So it seems like you guys are getting it. So I think you'll be able to do this assignment really well. The only thing I need to discuss a little bit is that Bing API. We'll talk about that in a sec. But actually, let's not just finish there. Okay. Let's do a few other things. Now, my classifier did pretty well, so you'll see. But that's only because of the nature of these images, which I always use intentionally to be very easy. As I said, I really want you guys to do something a little bit more challenging than this. So I'm going to do classification. I'm going to print out a few additional data. So interp classification, interpretation, dot from learner, learn, right? So the object name is learn over here. So we're going to plug that one in here as learn. And now we're going to plot out the confusion matrix. So I'm going to do interp dot plot confusion matrix. Confusion matrix. And we should be ready. So this prints out a nice confusion matrix. There you go. So please include this in your homework assignment also. As you can see, mine, you guys, I don't have to explain this because you guys already have taken 365 and 520. You understand everything. But basically, we want things to be on the diagonal, right? And as you can see, there's no misclassifications. Notice that just my test set here has what? 50, 60, it's 150, it's like 200. and it was out of 20%, correct? So was it 20%? Yeah, 20%. So really, we're talking about, I had at least 1,000 images. Now, my understanding, the API of Bing will give you about 1,000 a day, I think it is. So you'll be able to collect a good set of data. Okay, guys? All right. So now let's go ahead. So we started at 2:30. It is now 3:30. So we've got 10 more minutes, correct? Yeah, so we can finish. Remind me, okay, guys, because I might. All right, so now another thing that might be useful is to plot the highest losses associated with predictions. That is to say, as you guys know, as the epochs are getting better, the loss function should be going down. You guys know this, right? In the training, the loss function goes down, right? Goes down. That's usually what you want. But at the same time, it's predicting images. So it predicts an image here, it predicts an image here, you know, so to kind of assess, you know, this validation loss over here, right? So then if you think about it, we can kind of look at the loss and the images that it predicted. So what you might expect is when the loss is really high, it'll have more misclassifications. When the loss is really good, it'll have fewer misclassifications. So there's a function in fastai that allows you to do something like that, right? So we're gonna try that one, and I'm sure there's many more. This is just an example. We're gonna try out the plot top losses function, okay? Which shows us the images with the highest loss in our data set. Okay, guys? So that's basically the idea there. So it's a simple function. We just, from that same object, interp dot plot underscore top losses. We're gonna, look at 5 values. You can try more. And it's similar to the when we were printing the images, you specify the n rows equal 1. So this will have 5. Now you'll see that in mine, it actually won't give that much. See, it should show a lot of pictures here, but because the classifier was so good, I think, it only shows 1. So when you guys do this on your own data set, your own noisier, you'll have more errors. So you can expect to see that. This basically is the predicted and the actual Pepino, what the associated loss was, it was already 0. And then the probability that it thinks it's Pepino is 100%. So as you can see, this classifier does extremely well. You guys will probably have, image class 1, class 2, misclassification, high loss, not so sure of the probability. Okay? Does this make sense? This graph? Does it make sense? Any questions I should ask? Sounds like there's no questions. Making sense, I guess. All right. So as you can see, that's a pretty complete pipeline for machine learning. Now, the last thing you want to do, obviously, in transfer learning is you want to save your models. So if we want to save our model, we can just call learn.export. Right, and that will basically, there's several ways to do it, but this is the built-in fastai approach. This will save an export file called export.pkl, which saves the model. Now, this is useful. Let's say now you could use that learn export, or that export.pkl to build, for instance, with JavaScript, a website. And now from that website, you can call your model and perform various tasks. Okay, you can perform various tasks. So you can basically build a web application, is what I'm saying. Does this make sense? Although obviously this is not a web development course, so I am not going to get into that. The book does provide some data there, so take a quick look at that. If you're interested, it'll give you at least enough to get started with that concept. Okay, and so that's basically the whole pipeline. If you think about it, if we wanted to, the other part would be, if now, let's say you're somewhere else and you want to bring in this model. So let me run this one. I think I did. Now I had created this file, so hopefully I didn't, I probably overwrote it, I assume. Now, if you want to bring in that model, we could do learn inference. And then instead of export, we would say something like, we would say load learner. Okay, so we would basically now bring in the file export.pkl, And oops, sorry. And now we would be able to do predictions. So individual predictions. So for instance, what I'm going to do is I'm going to do learn inf dot predict. And I'm just going to predict on one of my images. I know the, so I have like fruits. And I'm just going to pick one image in the Apple folder. And it's called R99 100.jpg. Okay, so if I run this, it should tell me what label it is. And there it is. It tells me that it's an apple. It is an apple, in fact. And basically there it's giving me, we have 4 classes. It's giving me the probabilities. I believe the other day we worked on how to change this to non-exponential. There's a few tricks out there in NumPy that will do that. We can also print out the vocabulary that we have. So we can say learn inf .dls .vocab, and this will tell us the labels. Vocab, yeah. So I'm going to run this one over here, and you can see our classes are apple, banana, pepino, and pepper. All right, so that concludes the ImageNet lecture for today. Are there any questions? Does all of this make sense? Any questions? All right, so it sounds like you guys don't have any questions. So it seems like you're understanding it. It's important that you do, as you will have a homework assignment about this, but it should be a fun one. So let's do this. It's 3:48, right? So we're gonna run 2:30 to 3:50, and it is now 3:48. Let's take a 10-minute break because this is a good stopping point. I'll start generating the video for this one. And then when we come back, I'll talk about the homework assignment for this, and then we're gonna move on to NLP basically. Okay, does that work for you guys?
Yep.
All right, perfect. All right, so it's actually 3:49 now, so we'll start at 3:59. We will begin with the second half of today. All right, so I'm just gonna stop this. So it was recording audio, so I'm gonna just end it and we'll come back in 10 minutes.